Alright, so let's start with some weird ones that we've already done. Oh boy. Okay, like y equals 3. What did that function look like on the graph?
Horizontal.
Yeah, it was a horizontal line through y equals 3, like that. This function the book calls a constant function. Do you guys know why it would be called a constant function? Because 3 is a constant. The value of the function is always that one number, 3. No variables in here, just y equals 3 all the time. Okay, the other weird one that we've already done is, wrote them differently, not y equals, x equals like 2 or something. What did that graph look like?
B over 2.
It's a vertical line through 2 on the x-axis. This is actually not a function. You guys remember the first lesson where we did like mapping and function, not a function?
Yes.
If it fails a vertical line test, like if it hits more than one point, it's not a function. Because this would be like 1, 1, or sorry, 2, 1, 2, 1. This would be 2, 2 right here. And you can't have the same x value going to different y values, not a function. So that is not a function, but it's one of the weird things that we did. Okay, back in Algebra 1, we did this weird function. Y equals absolute value of x. I don't suppose anybody remembers what that looks like.
It's like a smiley face thing. I mean, a really high smiley face.
Okay, if you're not sure what a function graph looks like, you guys know how we can figure it out?
No.
Let's try some x values. If I plug in -2, what do I get?
2,
1, -1,
1,
0,
1, 2,
1,
2.
2. Okay, if I plug in those x values for x, I get some y values to go with it. These are the coordinates of the points on the graph. And I can plug in any x's, but I'm just sticking to the middle. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. What shape is this?
Smiley face.
Kind of a V shape. It's like perfect diagonal V's. This point down here is called the vertex. You guys remember what like a +2 did to this graph?
Move it up 2.
Moves it up 2. Like that.
How would you move it right or left?
Okay, what happens if I put the 2 directly on the x? Goes left 2. Wow. Do you remember that? Way to go. You're a champ. Yeah. So this would be like left 2 and down 1. So like boom, boom. It would look like that. That's not really what this lesson's about, but that's something we need to know for later. What else? There's another weird one. I have to look at the book. I think those were the only ones we were. Oh, well, this is not a weird one, but maybe confuses people. What kind of graph is that? We did this a couple days ago. It's got a slope and a y-intercept, right?
It's a slope of 1 through the origin.
So yeah, that's not really a weird one. It's just y-intercept 0, slope of 1 over 1. It's just a perfect diagonal. This is just a normal linear equation, although it looks kind of weird. It's got a slope and y-intercept. Okay, that wasn't the weird one. So the new thing that we have not done before, there's 2 of them. One of them is called a piecewise function. I'm going to use the one the book made, if I can find it on the page. Here we go. I wish I could fast forward to this. See?
This 4 subscribers won't get actually in the videos you can't really do what we say.
So I just looking for like 3 points on the graph.
No, these are not 3 points. So what they're saying is they split it up into 3 parts on this one. Piecewise, like there's 3 pieces to it. There could be 4 or 1 or 2, whatever. But they're saying when x is between -5 and 2, that the graph is f of x equals -3, which is like y equals -3. So here's my graph.
Alright.
So when x is between -5 and 2, so from like -5 is like right here, from there to there, we're going to graph y equals -3. What does the graph of y equals -3 look like?
Up 1.
Horizontal.
Horizontal through -3. So it would actually look like this. Okay, why did I put a closed circle and an open circle?
Because,
Yeah. And this one, -5 is included, but -2 is not included. So that's why. And then from x is -2 to 1, so from like right here to right here, 1's not included. I'm going to graph the line f of x equals x plus 1, or y equals x plus 1. There's a couple ways we could do this. Well, yeah, we'll just do the normal, slope, or y-intercept and slope, right? Y-intercept is 1, slope is -1 over 1. So you go down 1, right 1, or up 1, left 1, up 1, left 1. So from here to here, it's just that line. So in this part it's doing this thing, and then it jumps and starts doing this thing, and then the last part from 1 to 4, so like, well, I shouldn't color that in actually. So from here to here, we're supposed to graph the line y equals -x plus 4. I'll just make a little mark here. So it's supposed to go from there to there. 4 is included. How can I graph that? Well, the slope is, or the y-intercept is 4, the slope is -1 over 1, but I can't really draw right here because that's part of this section. So one way you could do this is just plug in x equals 1 and figure out what the y value is that goes with it. So if I plug in x as 1, I get -1 plus 4, y is 3. When x is 1, y is 3. So there's a point at 1, 3. And I could plug in 2 and see what I get. Probably an easier way though is just go ahead and start using the slope, which is -1 over 1. So it's -1 over 1. -1 over 1. Like that. I feel like I copied something wrong. I did. This was a positive x. Oops. So it should have been going up, not down.
Wow, it's usual.
So it should look like that. My bad.
It's like the algebra version of proofs.
No, not at all.
I just,
That tells me you have no idea what a proof is.
so how do you make it do like the slanted thing again? Where it goes from like 3.7?
Proofs are logical arguments, step-by-step arguments to kind of think of a math rule. What?
So how do you make it like, because right now it's above the line by 3. How does it make the slope go back down? Is it because of the...
This one?
Yeah, that one.
So we were graphing this. Slope was -1.
Mm-hmm.
Like
Go back down.
down 1 over 1.
And then, is it up at the high point because it's +4?
Yeah, like if the entire line, if it wasn't limited, would have looked like this.
Okay.
But yeah, we were only supposed to graph that between 1 and 4, so it just was this part.
Okay. I think I get it.
It's like a bunch of little graphs put together. Because some situations, there's not a function that maps it really well. Like maybe the temperature in March looked like this. So that's like two functions put together. So anyway, piecewise has its uses. It's kind of a mess, but okay, we got one more weird one. And they call it the greatest integer function. I can't remember if they kind of jump back and forth between f of x equals and y equals. Okay, it looks like that with little brackets around it. It's called the greatest integer function. All it does is it rounds whatever you put into it, it rounds it down to the next lowest integer below it. So for example, if I said if this is the function, what is f of 2.1 going to be? And that would just be 2.
Oh, my God.
Or what is f of 3.7?
3.
No, it doesn't round. It doesn't round to the nearest. It rounds down every time. So it's just 3. Okay, and this one might confuse us. What's f negative 4.2?
Negative 3.
What's below negative 4.2? Negative 5. Negatives are backwards. Okay. How about f of like 6? Yeah, it stays the same. The integer at or below 6. So the graph of this looks like, so when x is between like 0 and 1, and I should probably zoom in. Okay, it looks like that. So if you plug in like 0.5, it'll round it down to 0. If f of 1 stays at 1, 1.5 rounds down to 1. 1.9, if you plug in 1.9, it rounds down to 1. Anyway, it looks like stair steps. And negative, same thing.
So with that, you just.
That's what it looks like. Huh?
Yeah. So with that function, you just keep doing that?
I mean, I don't think we're really going to be graphing this, but that is what it looks like, yeah. Sound like a dog lapping water.
Trey, your sense of humor is broken. Sebastian's making noise and you're just going.
All right, page 85. Number 1. Number 1 is matching. What is y equals, what is that?
Absolute value.
It's absolute value, so it is
Ah.
A. Okay, number 3. What did I say that thing was called? That's the one we
C.
greatest integer function, C.
No.
Number 5.
It's not columns.
Okay, you guys remember what that picture made?
Wait a minute. It would be a straight line, so.
It's linear, yeah. It's just it's a weird looking line. It makes the diagonal line, right? So it looks weird, but it's just a line. Okay. Number 7. So on 7, we kind of did this at the beginning of this chapter where we were doing domain and range and function and stuff.
Yeah.
So do you guys remember what domain meant?
The one of the 4. What? X value?
X values. So to state the domain for number 7, we need to figure out what the X values are. So let's start with the smallest X value. How far left does the function go?
3. Wait. 6.
Left.
Negative 7.
6.
No.
Negative 6.
Yeah, I think it's negative 6. Yeah, it goes to negative 6. It goes 6 left. Okay. Is that X value of negative 6 included, or is it just approaching negative 6? Approaching. So that's basically me saying X is bigger than negative 6. What is the largest X value on number 7? How far right does it go? 2. 2. Is 2 included?
Yes.
Yeah, so I'm gonna put x is less than or equal to 2.
Oh, I get it.
So the domain, we did this like last Monday or something.
I get it. This makes sense.
Okay, and then the range is the y values, so that's like up and down. So what's the lowest y value? How low does it go?
We're looking just at the dots.
-3.
-3. Is -3 included?
Cool.
Yeah.
Yes, it touches -3, so notice I put y on that one. Then how high does it go?
6.
6. And 6 is included.
What is with this music?
You shocked that Mr. Odell's playing music?
Yeah.
I thought I was watching a video.
Yeah, it does sound like a video.
He was singing in the back of the classroom.
Dude, I know. I just heard him out of nowhere, and I'm like, come on, don't. He can
He
sing.
did the demon thing, right?
You know what you should do? Put a tambourine in your backpack, and when you start singing, start pounding it on your thing.
It's funny that he
Like,
says
everybody bring like
harmonica
harmonicas and stuff.
Tyler brought up the fact that he likes Bill and Ted, but doesn't like the water boy. Bill and Ted's
Okay, anyways, number 9, the domain. How far left does that one go?
1, 2, 3, -7.
No, is that right? Or is it -6?
6 or 7. I can't tell.
Okay.
1, 2, 3.
I think it's 6.
Man.
Okay, it goes to -6. Is -6 included?
Yeah, no.
No, it's an open circle. How far right does number 9 go?
3.
3, and 3 is included, right?
I was really
I got something.
Did Abby get something wrong?
Okay, the
wrong.
range is how low it goes, so how low does number 9 go?
Oh, no. Right.
What?
1. And 1 is not included, so I'll put that. How high does it go?
4.
4?
Yes.
Is 4 included? Yes, it is, because it doesn't matter that there's an open circle, because 4 is covered by a bunch of other stuff. Alright, number 11. Evaluate each function for the given values. Okay, this one's kind of weird. So 11 says f of x equals 5.
And
So that means no matter what value we choose for x, what's the function value going to be? 5. So it doesn't matter if we're doing f of 3, the function's going to equal 5, or f of -1, the function's going to equal 5. That is it.
wait, are you serious? That's the entire problem?
Yeah.
Wait, go back. Just go back. I was still.
See it?
No, I was still in awe of how simple that was.
This
That was
seems
just
like a trick.
incredibly simple.
Yeah, that seems like a trick.
Yeah, and yet none of you would have known it
You're right.
until now. How low can you go?
Let's do some things like. Just kidding.
Okay, number 13.
Well, oh,
How bad do you want?
I can do this.
Nothing?
What did he say?
Okay,
What do you think I said?
what did I call this function?
Yeah, we did it.
It would round it down. by-
Rounds it down. Okay, so on 13 when they say what's h of -3.2, whoops,
H of
Yeah, wait, what is that
-4,
X called? What's that called?
it's greatest integer function.
and
Oh,
then
that's
what do you do with a fraction? Do you just
Okay, it rounds it down, right? So what's below -3.2? -4. The next one is 7/4. What is 7/4 as a mixed number? 1 3/4. So if we round it down, what?
0?
1 3/4 rounded down,
No, we just do one.
1.
Oops.
Alright, guys, on 16, you plug in x first, right, and then you add 2, and then you do the absolute values. What's absolute value do?
Make them all positive.
Makes it positive, and then what do you do?
Multiply by 3.
Times 3.
Yeah.
So you do x plus 2, make it positive, times 3.
Huh.
Hopefully you don't get that one wrong. 15. This one is still the greatest integer function, but this time
You
it's
subtract.
subtracting.
Do you do it before or after you
What do you think?
before?
Yeah. You do inside first, and then whatever that is, you round it down. If they had put the minus 0.5 outside of it, then that would be different. But since it's inside the brackets, you subtract first. Yeah. You girls want the bin open?
Ours is mid open.
Don't ask Allison.
Go ahead and just scroll out.
Yeah, my bad, guys.
Actually, an inch too short. Oh, is that open?
Other way.
To the
It's
right.
pushed, it's like pushed to, yeah, like that.
No, it is more sweet.
Just to end up.
Breaks fighting.
Oops.
All happy toast
All right. So what's negative 1.5 minus 0.5?
and dream.
What's
Negative
negative 2? And if we round that down, it stays negative 2. Doesn't move. Okay, and then the next one is 5/4.
Plus, minus.
Okay, 5/4 is like 1 1/4, right? 1.25.
Yeah.
So what's $1.25 minus 50 cents?
75.
Okay, and if I round that down,
0.
0. To the next lowest integer, 0.
We did it.
17's really hard, I already did
So,
it. I'm gonna
Anything past the first page is always hard.
yeah, it's graphing.
Save for Monday.
go. What's your
Well, Bastion.
It's your,
God. Big Sunday.
I'm sorry I have long legs. I need to stretch them.
Thank you.
I would have caught
I doubt that very much.
you. You probably would have hit the table before I came.
Exactly.
I would have tried.
All right, back to graph paper.
Barely hold a water bottle. I'm not gonna trust your judgment. Barely hold a water bottle. Look at those noodle arms.
Have you seen
So
I
Mr.
should meet you in an arm wrestling.
Okay, let's say that I had no idea how to graph number 17, which might not.
We got a problem.
How could I figure out what the graph looked like?
Well, it probably was just a straight line.
What?
look in the back of the book.
What?
It's probably just a straight line.
No, it's not straight line. We talked about this one already, but how could I figure out what a graph looked like if I didn't know? Plug x values in and see what you get, right? But actually, we should know because this is the first thing we talked about today. What does the absolute value function look like? It's the first thing we talked about. What does y equals absolute value of x look like?
Or like a kind of
V.
Yes.
V. What would the plus 2 do to that function?
move it up to.
Move it up to. Okay. The minus 2, or, yeah. If I did plug it in, I would,
0, 1, 2, 10.
I would get that stuff. So, if you know the tricks, so you don't really need that. You just kind of.
Just so proud.
Okay, on
It
19.
says this is domain, Rich.
Oh, okay. What's the domain? X values, right?
So -2.
What's the lower limit? How far left does it go?
Infinite,
How far right?
infinite,
So what's the domain?
all real numbers.
All real numbers.
Range. How far down does it go?
Positive 2,
2. How far up does it go?
infinite,
Yeah, it goes up forever. So what's the range?
2.
okay.
Now that's just stuck in my head.
19. Do you guys know what's going to happen to the graph on 19?
No.
Where is it going to move? It's gonna be like a squiggly.
No. It's an absolute value function. So
Oh, it's going left 2, down 3.
yes, it'll move left 2 and down 3. If you did not know, you would have to just plug in x's, but it's going to move left 2 and down 3. So the vertex is left 2, down 3 right there. It just goes up. What is the domain?
All real numbers.
Yeah, it goes forever left and right, all real numbers. All absolute value functions. There's no limit to what you can put in. What's the range? What's the lowest y value?
-3.
3. And it goes up forever, so y is greater than or equal to -3. Alright. The piecewise function.
What's that?
These are going to be some doozies.
Oh, okay.
Mm.
21.
Thankfully, there's just 3 of them.
Yep.
That's 3 more than I need.
Okay, so between x equals -3 and x equals 0, we're supposed to graph the line y equals -x. You guys see where I got that from? Between x values of -3 and 0, we're supposed to graph the line y equals -x. So basically from here to here. Well, -3 to 0. You're supposed to graph this line. How do I graph that line? What is, it's just a linear equation, right? What's the y-intercept? What's the slope? -1 or -1. So y-intercept is 0, slope is -1 over 1, but it can't go this way, so I have to go backwards. So up 1, left 1,
Oh, that's
1 left 1. -1 and 3, whoops. -1 and 3 are both included also.
so all of it is just 1. Brilliant.
-0 and -3 included. Darn. And then on the next part it says 0 from 0 to 3. It's just going to be equal to x.
So is that
Like
just
the line y equals x. So that's from zero's included on this one also. So from 0 to 3, y equals x. So what's the y-intercept of this line? 0. What's the slope?
1.
So we're starting at 0, going up 1 over 1, up 1 over 1, up 1 over 1.
I think I'm starting to understand.
And what does it say? From 3 to 6, so from here to here, we're supposed to graph the line y equals negative x plus 6. Okay, so if I was doing this one, so the y-intercept is way over here, 6, but we're not supposed to graph in this range. So let's just put in y equals 3, because that's where it starts, or x equals 3, because that's where it starts, and see where this thing will start at. If I put in 3 for x, what do I get for y? 3. So that means 3, 3 is a point on the graph, which, a coincidence, that's where we left off on the last one. And I could like plug in 4 for x and keep doing that, but I know it's a line because this is the equation, and I know what the slope is.
So it makes it about 6.
It's negative 1 over 1, so it's going to go down 1 over 1 again, all the way to 6.
Can we do another one of those?
Down,
Just
up, down.
Maybe like 20.
Yeah. Please. Because I'm not sure I entirely get it.
So on number 20, it just says f of x equals 1 on the first line. What does that mean? It's the line y equals 1. What does the line y equals 1 look like?
Do you start 1 up?
Yes, it's a horizontal line through y equals 1. But that only runs between x equals negative 5 and x equals 1. So you draw a horizontal line at 1 from x equals negative 5 to x equals negative 1. That's how it starts. Let you guys look at it and try to figure it out.
Okay.
I was talking about 20.
Okay.